This limit stumps a lot of people. So all we need to do is solve this limit as n approaches infinity. Now, as you can see, we add two functions together, and we already know the limit additions law. So let's go ahead and break it up accordingly. Okay, so we should be pretty comfortable with this part, but the part I want to emphasize is this right here, because specifically we are multiplying a constant times our function a of n. Now, if you remember the constant multiplication law, it says that if we're multiplying a constant by a function and taking the limit of it, that's the same as multiplying the constant times the limit. So what we see up here is exactly the same as what's in white right there. Unfortunately for b of n, that can just stay the same. So focusing on our a of n limit first, let's go ahead and substitute our function for a of n. At this point, I would normally say, well, let's try to break this up into its factors to see if there's any cancellation. But here we don't have to do that. Why? Because we see our limit is as n is approaching infinity. All that means is that n is getting bigger and bigger and bigger. So it's not about trying to cancel or nothing like that. Let's just see, does the top or does the bottom grow faster than the other? Well, looking at the top, we have 3n squared, and at the bottom we have 2n. What does that tell us about this function? Well, it tells us that as n gets bigger and bigger and bigger, the n squared is going to get bigger and bigger and bigger quicker. And of course, if the numerator gets bigger than the denominator, then that means that this limit just gets bigger and bigger towards infinity. Now let's not forget, even though we've done the limit here, we still need to multiply by our 1/4, but it's not going to matter, because infinity times any value always just equals infinity. Now, how about our b of n limit? Well, we can go ahead and substitute b of n first. Alright, are there any sort of competitions of n going on here? Well, actually, no, we don't, because the only n term that we have is that one right there. So naturally, as n gets bigger and bigger and bigger, or approaches infinity, then this function only gets bigger and bigger and bigger, heading off towards infinity as well. Alright, now that we've evaluated both limits, the only other thing that we have to do is add them together. So we get infinity plus infinity, and that equals, it's infinity. Well, I hope this brief little walkthrough helped today. Is there anything that could use a little bit more explaining?